Oh, okay. All right. Well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Yes, Mr. Q. All right. Warm-up number 48 should come up as soon as you log in. Stay focused. Today we're gonna look at probably what we've done so far the past 2 weeks, and let's see how you do with the warm-up. It shouldn't be that rigorous, but I think you got it. Give you a head start. If you have questions, ask your neighbors. Or should I say, if you have questions, ask Brandon Doherty. He's got it. All right. So let's get started, please. Go. All right. Looks like Amelia's almost done. Very good, Amelia. Of course, Brandon Doherty's already done. Very good. But let's see. Get us started with our next step. So look up to the screen. It says, compute the standard deviation for the grouped data sample. Okay. We are given class boundaries. We're given frequency. What do we do next? Tell your neighbor, please. What do we do next? By now, your noodle should take over, yes? All right. So, what do we do next, Mario? The midpoint. Yeah, Mario, without skipping the beat. X sub m. That is correct. Midpoints. So, pass someone so they can give us those midpoints. Santi, what'd you get? Uh-huh. Yes. 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 14. Blessing. Blessing. All right. So we got the midpoint. So far, so good. Yes? Yes, Mr. Q. He loves these. All right. From there, what do we do next? Let's see if the color helps you. Tell your neighbor what to do next. And then Santi's going to pass someone. All right. Santi, pass someone. Aaron, what do I do next? Frequency times? Frequency times the midpoint. That is correct. Ooh-wee. So we got 11 times 2. That's 22. 12 times 5, that's 60. 4 times 8, that's 32. 2 times 11, that's 22. 1 times 14 is 14. All right. Not bad, not bad. Yeah, you guys are pretty good. You guys remember of me in, remind me of me in kindergarten. Let's go. All right. Next, I'm going to make another one a little bit longer and remind your neighbor what would be our next step there. What is our next step? All right, good conversations. Aaron, pass them on. Brandon, Darty. Bam, frequency times midpoint squared. That is correct. So our frequency for the first one is 11 times midpoint squared. So 2 squared is 4, so that gives us 44. The next one is 12 times 5 squared, that's 25. So 25 times 12 is what, Amelia? 12 times 25? 300. There it is. Then we got 4 times 8 squared, that's 64. Pass someone? Logan? 256. Then we got 2 times 11 squared, that's 121. And I'll do that one, that's 242. And then we got 1 times 14 squared, that's 196, so that stays 196. All right. Next, remind your neighbor what to do next for those 2 columns. What do we do next? Tell your neighbor, please. All right, Logan, pass someone. Brandon, Darty, what do I do for this one? All right, the sum for this one, which is 150. All right. And how about the sum for this one? Pass someone. Melina. 1,000 what? 38. Woo. So, let me write this out correctly just so that we can have the label correctly. So here we did the sum of frequency times midpoint. And this one is the sum of frequency times midpoint squared. All right, so with that said, they're asking us to find the standard deviation of grouped data. So look at the end of your notebook and tell your neighbor which formula we're going to use to find the standard deviation for grouped data sample. Talk with your neighbor. What is our formula? All right, pass someone. Brandon. Oh, Melina, pass someone. Good. Brandon, what's the formula? What?
Get down.
What?
Did you press something?
No? Even the projector went out? What? I guess we won't have a lesson? No. Give me a second.
Still must go on.
It should. Who was helping us out? Oh, Brandon. All right, formula. Tell me what's right. To me? All right, so Brandon passes it to me, and I'm going to pass it to Brandon. It says grouped data. And, of course, you have all your formulas labeled, so you should know which formula to use. All right, tell me what to write, Brandon. I'll give you a hint. S equals N times the sum frequency times yes. Well, give me the formula. F times X midpoint squared minus the sum of the midpoint with a squared outside. Okay. And then? Ooh, Melina in the house. Let's go. All right. So, let me highlight what you need to substitute in there. So, in blue, the blue goes here. And the red goes here. And N, let's see. What is how many total frequencies do we have, everyone? No. 30, all right? So that's our N. All right, so thirty times 29. And then we got 1038. And then we got 150. Which one's Cole? This one? 44. This one? This? Oh, my bad, my bad. It's an S for sample standard deviation. All right, calculators, calculate. What'd you get for standard deviation for that group data? All right, looks like Diani's got it. Austin's got it. I see you, Austin. Of course, Alessandra's got it. Very good, Alessandra. Let's go. Well, let's go with Lulu. What'd you get? Standard deviation is 1, 2, 3, 4, 5, 6, 7. Mm-hmm. Square root. You got the variance? Okay, what's the variance? 83, 52. Standard deviation is 91.3. Hands, have you got that? No? All right. Right here. All right. Yes. There you go. All right. So, double check, guys. Your computation, 30 times 1030 minus 150 squared divided by 30 times 29. Standard deviation, double check, please. And Diani's going to double check our numbers here with her calculations. All right, let's break it down by parts because it seems like some of you are like wondering what's going on. Come on, people, it's just crunching numbers. 30 times 1038. What is that? $31,140 minus 150 squared. $200,000, 22,500 divided by 30 times 29. 8 what? 70. So then still, I'm going to get you closer. 31,140 minus 22,500. 8,640. tell them if I can call them back to let you know who it is. 8,640 divided by 870. The variance is what? 9.93. So my standard deviation, you need to take the square root of that, and that gives me 3.15. Woo! Come on, people. Let's go. All right? Yes? All right, send that in, please. Let me send you the screen. Amelia, who was it? They were looking for who? Again, I told him that he's in first period. Okay. All right, copy the agenda. Warm-up number 48 done. Today we're completing the measures of variations for coefficient of variations. And tonight, study, 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 all right? We good? All right, here goes. So last night's home play was these three. I'll open up the assignment in a little bit. I just want to get us started with the next portion. All right, get a Cornell note ready, please. I can summarize data and compute the measures of variation. I can summarize data and compute the measures of variation. We're still in the middle of those. Hopefully by Tuesday we'll be done and move on to the next section. And by now, we should know the definition in our own words for measures of variation, yes? Yes, Mr. Q. Type it in on the screen, please. 30 seconds. Some of you might be wondering, oh my, Mr. Q, how come you keep giving us these every day and being that tomorrow's Friday? 10, 9, 5, 3, 1. Thank you. Yes. All right. Something like that, yeah? All right. Next, 45 seconds, fill in the gaps, go. And once again, by now you should know each one of those and where we're headed. On, Alessandra, let's go. Pen Q, no, I said pen Q, for working so diligently. Pen Q. Did I tell you guys that story about 10Q? Yeah? All right, quick story as you're finishing up. I used to do trainings throughout the state for math teachers, and I would end my session with a screen that said 10Q. So 10 years later, I bumped into one of those teachers, and they're like, Mr. Q, can I ask you a question? I'm like, sure. I didn't have the nerve to ask in front of all the other mathematicians, but what does 10Q stand for? And we're like, 10Q? She's all like, wow. Get it? 10Q? Yeah. Anyways, we got it? Yes? All right, good. So far, so good. And of course, you know your formulas, yes? All right, go to the back of your notebook, double check to make sure you have all of those labeled. Brandon dot, oh, he's not here. My goodness. By now you should have the formula with its proper name. Double check them, please. We have 2, 4, 6, 8, 10, 12, 14, 16, 18. What? 18 already? Let's go. Some of you are like, Q, just bring it. Give us another formula pop party. Let's go. Hi, Angela. Right? All right. We good? All right, take a screenshot in case you need to save that for later. Here it goes. I wanted to get us there for the next section. So yesterday we talked about CVar, yes, cake. We did an example here in class. Another, you ended up with this one. Is that correct? All right. So, bless you. Copy this one. However, turn to your neighbor. Let them know which of those datas are you copying, Europe or Asia, and your neighbor is going to copy the other one. Tell them which one are they copying. All right, so copy that, please. You don't have to copy the problem, but I'll read it out loud. It reads, example super duper Q reads, starting teacher salaries in equivalent US dollars for upper secondary education in selected countries are listed below. Which set of data is more variable? Does that sound familiar? Variable, yes? Yes, Mr. Q, is what we did yesterday, the CVar. Okay. Which one is more variable, which means CVar? Okay. So think about this. Let's see. Oh, Brandon Doherty's back. Think about this. Variable. So, to check for which one has more variable, what would be our formula? Brandon Doherty, without looking at your notes. CVar equals standard deviation over mean times. That is correct. So if that's true, guys, that means we need to find what? Standard deviation, is that correct? And what else do we need? The mean. So let me pause the music in the background. Look up, please. Writing utensils down. Writing utensils down. Eyes up here. Here we go. So, Brandon Doherty told us that we need this formula, which implies that we need the standard deviation, or what? Our mean. Okay. So you have data in front of you. Is this a group distribution? No, Mr. Q, it's just data. So watch. Look up. Look up, please, or you're going to miss it. If I was to cover, and I'm trying to do this so you don't get distracted, if I was to cover all the information there and just left you this data, tell you never the first step you would do in order for you to come up with a standard deviation. Talk to your neighbor. What do we do with that data? All right. Let's see. Brandon, pass someone. What do we do with that data, Chloe? Okay, so you're going to leave it in that order. That's fine. So she said you add it, and then what? Divide by the number of numbers. So 1, 2, 3, 4, 5, 6, 7. Okay. And what is that called? The mean. That is correct. So that would take care of that one. And what do we do with that mean? What would be the next step? Talking to your neighbor. What would be the next step? Go ahead and pass someone. Kieran. Yeah, subtract the mean from each of these all the way down, right? And we end up with a number here. What do we do with that number after we subtract the number from the mean? Talking to your neighbor, what do we do with that number? Kieran, pass someone. Vianney, what do we do with that number? Close. Before that. That is correct. You square each of them. Once you square them, you end up with another number. What do we do with all that? Tell your neighbor, what do we do with all that? All right, good conversations. Yanni, pass them on. Add them, and then you find the mean, but it's no longer known as the mean. What do we call it now, once we add them and divide them by the number of numbers? Start with the letter V. Variance. That is correct. Sample variance. And in our last step, we need to find our standard deviation. What do we do with the variance, everyone? Square root. All right, so now you know the process. So you're doing this data, your neighbor's doing this data. Once you do that, substitute your values into the formula that Brandon Doherty told us, the CVar. Come up with a percent, compare them, see which one has more variability. I'll give you guys some time and go. So at the bottom, I wrote in blue for the first set of data, CVar equals blank times 100. When you get there, the second set of data for Asia, I wrote that in green. So I'll leave it there for right now, and then we'll talk about it once you are done. I'll give you some more time. For Europe, Alexandra, what'd you get for the mean? And 37, okay? Hands, if you got that, those of you doing the Europe for the mean, that is correct, by the way. You find the sum divided by 7 should have given you 34,637. Then, subtract that from each of these numbers, square them, you end up with big numbers, yes, like 100,000s and stuff. Well, millions, and so on and so forth. But they're just numbers, guys. And then from there, you add them, divide by 7 again, and that gives us the variance. So, variance, Europe. Let's go with Mario. Variance. Let me move this over. So it's either you or your partner or your neighbor. What did you get for the variance? Point what? 0.14? Hands, have you got something like that? Yes? No? Maybe so? Sense of disturbance in the force. Biani, what did you get? I know your neighbor. Yeah. What did they get? Now, so you're getting confused. The second mean is known as the variance, the second mean. Yes? Yeah? You too? All right, okay, which means Austin S should have the standard deviation of that. Is that correct? $632? Close enough, yes? All right, so now that we have the mean and the standard deviation, we can do the CVar for this one. Is that correct? So that means we got 34, 632 divided by 34, 637 times 100. All right. Austin S., what is the percentage? Yeah. Yeah? 34,632 divided by 34,637 times 100. What is it? 99.8%. 99.98. Okay. I think there's a mistake somewhere here. I just wanted to say it out loud. Yes. This one? So where do we get 34,000? The mean is 34,637. Okay, so what is our standard deviation? Oh my goodness. Okay, 6,000 what? 6,990. 6,990, like that? All right, that sounds a little bit more closer to what we need. Yeah, because 99% is like too high. So this is 6990 divided by 34,637 times 100 should give us 20 point what? 18. That sounds more like it. That's the percentage for Europe. So find me the percentage for Asia. Ask your neighbor. They should be done by now. CVar percentage. It's like Aleshka's done. Very good, Aleshka. Let's go. Yeah. Got 3 minutes to the bell. Okay. Bless you. All right, so let's pass this to Quirin. What'd you get? What? Oh, you did Europe? Oh, so then Asia was who? Aleshka, what'd you get? 45.03. Hands, if you got that? Yes, that is correct. So out of the two, which one's the one that is unstable or more variable? This one. So what does that mean, Mr. Q? That if you go to Asia to get a teaching job, your options for salary vary big time. So where would you be applying for a teaching job if you were to apply for a teaching job? In Europe, that is correct, because it's a little bit more what? Stable. That is correct. You would go almost and have a good frame as to where it's at. Send me your notes, please. Here it goes. There's a screen. All right. So tomorrow's problems are not going to have thousands of values like this one. All right. So tomorrow, hint, hint, wink, wink, you might get into teams of 2, do this again, and make a poster and make a video explaining your portion and the CVar for both. Yep. We'll stop right there. From 1 to 5, how comfortable are you with all this? Yes? 5, 4, 3, sorry, 4s, 5s, all right? We'll stop the video right there. Those of you on YouTube, make sure you get some practice in. See you guys next time. Peace.